Okay, so 10.1, Introduction to Logarithms. This is new stuff. You guys haven't seen this before. So first things first, a logarithm function is the inverse of an exponential function. And you guys have worked a lot with exponential functions in past math classes, a little bit in this class, not too much. But basically, an exponential function is just some base. It could be a number, it could be a variable, to a power equals an answer. That's all it is. So a logarithm is just another way to write an exponential function. So it's just another way to write this. So this is a logarithm right here. And basically, this is log base b of x equals a power. So I'm just going to write this. So this is the base. So b is the base. X is the answer. So it's the answer of the exponential function. And p is the power. So this is log base b of x equals p. So log base b of x equals p. That's how that is said out. And over here, this is the base. This is the power. This is the answer. So the easiest way to remember this, the answer to a logarithm is always the power of an exponential function. So the answer to a logarithm is always the power of an exponential function. I would maybe write that down. So the answer to a logarithm is the power of an exponential function. So this is always the power. That's why I labeled this P. Okay. So let's go through some examples. So convert from a logarithmic function to an exponential function. So basically that's finding the inverse because these are inverses of each other. So remember, we're just going to do this. So base is always your little letter right there. So that's going to be x. Whatever it equals is always your power. So x squared equals 9. Okay. X squared equals 9. And another way to do this, you can kind of make an E. So if you go down right here, that E will cross through 2 and go right there. See how that makes an E? So x squared equals 9. Okay, we could do the same thing here. So it'd be 4 squared equals 16. 4 squared equals 16. Because it's a base 4 to the power of 2 equals 16. And 4 squared really is 16, so we know that we got that right. Same thing here. You could make that E if you wanted to. And that'd be 9 to the 1/2 power equals 3. And anything 1/2, that means that's the same thing as the square root of 9 equals 3. If you guys can remember those rules of how to convert from a radical to an exponent. Okay, and the square root of 9 does equal 3, so we know that we wrote that one right. Okay, and then for this one, we're going to just convert this to a logarithmic function. So this is going to be log of our base, which is 9, of 81 equals x. Okay, and you can kind of make an L with this if you go down over. It's kind of a weird L. I think there's a better way to do that. But so 9 to the power, or 9, log base 9 of 81 equals x. So log base 9 of 81 equals x. And see how that kind of made an L? Yeah, anyways, if that L thing doesn't work for you, then don't do it. But basically, so it's the base, and then the answer equals the exponent, because it always equals the exponent. Like this one would be log base x of 243 equals 3, because it equals the exponent. So these two, the bases are always the same. These two are kind of what switch places. So then again here, this would be log base 2 of 16 equals 4, because 2 to the 4th equals 16. Okay. All right, now we're going to use a calculator to approximate each of the following. Let me find a calculator. Okay, so there's two different kinds. There's two special kinds of logarithms. So there's a seriously can't talk. So log of x. So this doesn't have a base like these did. See how these all had bases? So if it doesn't have a base and it just says log of x, you assume that the base is 10. So a log without a base has a base of 10. And that's true all the time. So if it doesn't have a base, then it's just a 10. You just assume that it's 10. So, and this is, when you say this, it's log base 10 of x. That's how you would say that, log base 10 of x. And then ln of x, this is a different logarithm. Ln of x is a log with the base e. Okay, and e is Euler's number. So e is like pi, it's just a mathematical irrational number. We even have an e button in our calculator. We're never going to have to use this, but I'll just show you. So right here at the division side, if you go second, it puts out that e. And so e equals 2.71828, blah, blah, blah. Okay, that is what e is. It's that number. So this ln of x is log base e of x. That's how you'd say that out loud. Okay, so we can find these two, so log of 4 and ln of 4, just using our calculators, because we have a log button, we have an ln button. So see how there's a log button right here next to the 7? I can literally just put log of 4, and it will give me that answer. So that's 0.602, log of 4. We can also do ln of 4. So ln of 4, 1.386. So ln of 4 is 1.386. And that's all you do on those two. Super easy. So if it says to find these using your calculator and they don't have bases, and if it's ln, you just push ln. If it's log, you just push log. Pretty simple. So then on these ones, so if it's not just log or ln and you do have a base, there's still a way to find these in your calculator. And it's the change of base formula. So basically, log base a of x, you take the big one. So not the base, but the big one that goes on top. And then the smaller one goes on bottom. So the one that's further up goes on top, and that'd be log of x divided by log of a. That will give you this answer. And you can also do it with the ln of x and ln of a, and you'll get the same answer. So you could use the log button or the ln button, and it's the same thing, just whichever one you prefer to use. Okay, so let's look at this example right here. So this, we have to use the change of base formula here because this isn't just a log. This has a base, so I can't just put log of 9 into my calculator and it won't give me the right answer. So in my calculator, the big one always goes on top, so that's going to be log of 9 over log of 4. And I just put that right in here. So I'd go log 9, close the parentheses, divided by log of 4, and I get 1.585. So this equals 1.585. And remember, I could do this with ln also. So I'm just going to show you that. So this is the same thing. I could go ln of 9 divided by the ln of 4. And I could put that into my calculator. So I could go ln of 9 divided by ln of 4, 1.584. That is the same exact thing. So you can use either one of these, get the same exact answer. So this is 1.585. Okay, let's do one more example. So again, we have to use the change of base formula here. So you can use log or ln. I'm just going to use log. So that'd be log of 7 over log 1.4. And I just put that in my calculator. So log of 7 divided by log of 1.4, entered 5.783. 5.783. And that would be the same answer if I did ln of 7 divided by ln of 1.4. I could do that again. So ln of 7 divided by ln of 1.4, not 494. And I get the same exact thing. Cool? So make sure you take the quiz. And if I were you, a lot of you don't take notes on this, I would, because this has formulas on here. I know this isn't a super hard concept, but I don't just make these notes because I like to do it. I make them to help you guys, okay? So take the quiz. Make sure you took notes on this, and I'll see you guys tomorrow.